Right, welcome everybody to the talk, Your Software Architecture May Aid Global Warming. Here you can find all the details where to reach me. Today I'm going to try something new. I am going to give my presentation using the place I call home. It's IntelliJ, or my IDE. And we're all software developers, so I think with great power, because we do have great power, comes great responsibility. And me personally, since I have kids, I'm quite concerned about global warming, and that's right true. I don't think we should call it global warming. We should call it a climate crisis. So I see a lot of companies going by default to microservice architecture these days. And what's not to like? Well, typically, if I go to a microservice project, this is how I feel. You see all these little ships, and they're all strung together. We're doing HTTP calls to one another, but we have the dual write problem. And to be honest, perhaps it's just me, and I've been in different companies that don't do it well, but I've not seen it done right a lot. In fact, I would even call it like this. We used to have microservice. We used to have a monolith, but now we have microservices. And it is even so bad, and I should perhaps zoom in a little bit. Let me try that. I heard you like microservices, so we created even a microservice to manage your microservices. And this is in fact the case with all the KDA tools out there. But let's continue. Oh, yeah. There is now even a book written, Microservice Release Management for Dummies, Best Practices on how to coordinate microservice releases, because it's such a hard topic. But that was always my feeling, and I thought, perhaps have a look, what is the rest of the world thinking about this? So I did some Google searching, and this is from Kelsey Hightower. I don't know whether you know him, but he is the man himself at Google working full-time on Kubernetes. And he says, quote, he prefers to package those components as a monolith because it offers a serious reduction in complexity and simplified deployment and management process. Again, this is from the guy who is paid by Google to work on Kubernetes. Steve Smith, he is also a great developer, organizer of a big conference, and he sums it up quite nicely. It's Kubernetes Kafka Istio. It's a tool that perhaps 95% of the world just doesn't need. I don't say there are definitely use cases, but should we just blindly follow the whole microservice architecture pattern? And then probably everybody knows this already, but even Amazon now switched back from microservices to a monolith. And hey, they have now a staggering 90% less costs because of it. So now we know that, and I feel that I'm not the only one. I thought, okay, I'm still concerned about the environment. How much energy does the internet consume? Well, currently, the internet consumes about the same amount of produces the same amount of CO2 than the global airline industry. So that's quite a lot. And what I found strange is that there are not done a lot of studies around this, because you find a whole lot of studies about open source developer burnout and all of this, but not how much the different software architectures, how much energy they consume. There's one study, and I always included the references, that said, yeah, currently we're around 2% of all the global energy that we use with where it probably will scale to 5% by 2050. Yet another study mentions that we are already using 5 to 9% of the total electricity for ICT needs. Well, yeah, there is also porn. And one of the most popular porn sites uses more than 6 million kilowatt just to power their streaming services. What is the conclusion of their study? Well, no one expected the world to watch so much porn. So yeah, that's also, again, related. Then how much energy does it consume if you look in the different industries? And well, data centers use 33%, which is like the majority of all the different energy usage. And there are even all the data centers together, they use more electricity than some countries. And yeah, in the beginning, it's like Nigeria, Colombia, these are all small countries. But then there's Egypt. Egypt has 100 million people. That's 10 times Belgium. And the UK is not far away from the amount of energy used by data centers. So, yeah. Then I tried to find different studies to find, how can we improve our software to make it more energy efficient? And then the first thing I found, and I'm copying someone else here, namely Josh Long, well, the programming languages matter. And if we have a look, C, it's one. It's best that we can do. Rust, we all know that Rust is quite good. Ada, I don't know it, to be honest. And then there is Java. 2, it's twice as inefficient as C. But if we go down the list, we find C#. It's already 50% more, in fact, than Java. Go, I always thought Go was really performing. Then we've got JavaScript, which is 4, and TypeScript is 21. I thought those two were like the same thing. Well, apparently not. So that's that. And then I wanted to know software architectures and energy. Is there something around, a study already done around that? Well, there is one study, it says there is a lack of initiatives to measure this. So the relation to the architecture and the energy perspective. But searching further, I did find one study. And again, the paper is referenced here. And what they did is they created the same application once in a monolith and once in a microservice architecture. And then they measured it. And for the monolith, they tested it during 3 minutes. I know, I don't think it's long enough to have some decent measures, but at least we have something. And this is like the CPU cost. And overall, it was 3 for the monolith. Then they split up everything in different microservices, and they got to 10, the total of 10. So this means that our microservice architecture typically needs 3 times more energy than just a monolith. And to be honest, the study is missing quite some stuff, because typically extra databases, the network traffic that needs to be also measured, that also consumes energy. There is more RAM usage. So we don't have a complete picture on that. And then you ask me, if not microservices, what else? What should we do then? Well, I want to introduce you, and I scratch the word introduce because it already exists for quite some time. I want to present to you the modular monolith. And what it is, in fact, it's a microservice architecture that you just combine again, but you keep the vertical slices all. And that means that the accounts model, for example, although it's packaged in the same application in the end, it cannot reference the orders module or the products module, for example. And last thing, what I want to give you during this session is some tools so that you can make like a good modeler monolith. And I think there are two. One is ArchUnit. It's a great tool for architectural unit tests. And the other is JobRunner. And now I'm going to do some self-promotion because I'm also doing the main development behind JobRunner. And I created some code to show you all of this. So I made like a really small application for Vox Days where we have an agenda, like the schedule, and all the attendees that are coming. And the first thing that I want to show you is ArchUnit. And in ArchUnit, we can have dependencies tests. What does that mean? Well, I can write tests where I say that the agenda classes can only depend on everything which is in the agenda module. And I took like this is the really verbose way of creating this test, but why did I choose this one? Because then it's easier to explain. What do? We get all the packages from be.voxdays, and then I just create a rule, and I say that the classes that reside in the package agenda should only depend on classes that reside in the package agenda and Java. And I did the same thing for the attendees. If I run this test, and why do I like this? As an architect, we sometimes switch from positions, we go to other projects. I still like to know that the project that I leave behind, that it will keep on being maintained well. And by putting in these kinds of tests, I'm quite sure that new people arriving on the project and that do not know the complete context of the project can still keep it in the way that we originally discussed with the team. And we see a failing test. Well, if we go have a look, it says that there is, I'm just going to click on it. And what do we see? Yeah, the agenda service is being called by the attendee service, which we originally said it would not be allowed. So ArchUnit. And then the other thing I quickly wanted to show you is JobRunner. JobRunner is a tool to run distributed background jobs with ease. And what does it allow you to do? I think that if we want to have like almost instant real-time information about some events, that you just need to pre-calculate it when these events come in. Instead of everything calculating everything real-time, let's pre-calculate it, and this can be done by a job. That's one use case. Another use case is here, for example, to send a lot of mails. And what did I do? Some really ugly code without a lot of tests, but I want to send each attendee, in this case, an email. Hey, Vox Day is coming up, and this has a title, a subject. It's all easy. I think everybody understands what's happening here. And if I run this class, voila, it's running. The job immediately starts. And for the example, I only put in 2 emails. But if we now go to localhost 8000, JobRunner comes with a built-in dashboard that allows you to monitor up on all of your jobs. So what does it mean? You can see what's happening. There is even instant updates, and you can log within the job. Not only that, it will automatically retry if you have a job failure. So that means that in a microservice architecture, if something goes wrong because another service is down, JobRunner will automatically retry. So that's it for me. I wanted to introduce you to some tools. Don't just blindly copy everything which is done on the internet. That's it.